Okay, so is that visible to you, Mark, and everyone?
Yes, I can see that very clearly.
Perfect. Okay, so good morning, as I said to everyone. As Mark mentioned, I'm Pat Tuohy, and the title is as you see on the screen. So what we're going to run through today is a look at, in the context of greenhouse gas mitigation, what the role of land drainage is, and water table control. And there's a slight separation there, which I'll get into as we move through the slides. So I suppose the background to this, and some of you have been seen a number of these seminars, Friday morning seminars at this stage. Um, and what's driving this, of course, is a number of documents and papers that are out there at the moment and that are driving policy going forward. From the Teagasc point of view, the MAC curve document, the abatement potential of greenhouse gases emissions in Irish agriculture, and that has formed part, obviously, of the government response in terms of the climate action reports and the climate action plans that are fairly recent documents. And in each of those, and I suppose one leads to the other leads to the other, but in each of those, you'll see that the role of mineral and organic soils comes quite heavily in what roles they might be able to play, and the management practices that might be used to mitigate greenhouse gas emissions, by treating those soils in particular ways or managing those soils in particular ways. So to go back to the first document, I suppose, and the Teagasc document, the MAC curve, there's a number of measurements in that document, and I'm sure a lot of you are familiar with it. But I suppose from the context of today and what we're talking about, land drainage and water table control, there are the three that you see there that are the major headline figures in this whole area. So measure 10 looks at draining wet mineral soils. Measure 7 comes, I suppose, under that draining of mineral soils heading as well to a certain extent, and we'll see that in a moment. And measure 17, water table manipulation of organic soils, which is referred to in some of the writing and some of the context as re-wetting. So I suppose the draining of wet mineral soils is going to be a continuation of a lot of work that's already ongoing. The water table manipulation of organic soils, or the re-wetting of peat soils, as it's termed, is a kind of, I suppose, a new venture and something that we have to bring to the fore as we move forward, and it's something that seems to have certainly caught on in terms of the public discourse and public imagination of this whole issue, and the amounts of carbon that may or may not be sequestered or be stored by manipulating water tables and organic soils. But the two figures that are there in red text, mineral soils and organic soils, I suppose, is where the big distinction is drawn, and it's in the case of any process or any management that involves soils, there's obviously a whole lot of differences, or an array of soil types, an array of materials that you're actually dealing with, and how to deal with those varies hugely. So I suppose just to touch off both of those, what the definitions, or what a simple, straightforward definition of each of those is. We see there, and I suppose a picture painting 1,000 words here, but mineral soils, as it says, they are derived from mineral matter, so sand, silt, and clay, which are familiar terms, I would hope, for a lot of you. Larger particles then is just referring there if there's stones or gravel or whatever, but mineral matter is the principal part that makes up mineral soils, and then you will have any soil sustaining life or supporting life, or growing plant and animal life has a certain amount of organic matter. As that life dies and decays, that organic matter is stored in the soil, and principally within a couple of centimeters of the surface is where a lot of it would be stored, but it's there within the soil profile, but generally less than 10% organic matter in those soils, and tend to be, I suppose, some of the lighter colors as you're seeing there, some of the more productive soils, I suppose, and tend to be obviously fairly widespread around the country. The other side of the coin then is the organic soil. So you've moved far beyond the 10% here in terms of what the organic matter portion is. Peats possess an organic layer by definition that's at least 20% organic carbon and have a minimum thickness of 40 centimeters. Histic soils, sometimes referred to as the drain peats, but a peaty O horizon, which is an organic horizon, a thickness of 7.5 centimeters or more. So these, as I said, are the other side of the coin. The dominant feature here is the organic matter and the mineral matter. Again, there's going to be mineral matter there to an extent throughout the profile, but the dominant feature, the dominant makeup of the soil is the organic part of the soil. And then I suppose just to throw a bit of confusion in, there is the kind of halfway house of what's termed sometimes as the organo-mineral soil. So there's a longer definitions of this if you go into the literature and how this is defined, but just for the purposes of today, the main thing there, humic soils, an A horizon, so the surface horizon, significantly more organic matter than mineral matter. And you can see there again, even by the two photos that are shown. So you have, as you get down into the subsoil, about what's marked as 40, which is about 40 centimeters in both those photos that you're looking at, is predominantly mineral matter, different coloring as you can see, but predominantly mineral matter in both those cases. But on top, you're looking at these darker horizons and potential there that you have, as it says in the headline, more organic matter than mineral matter. So they're kind of a halfway house in terms of I suppose, some of the hit behaviors of mineral soils and some of the hit behaviors of organic soils, depending how they're treated. So that's a quick run through, and as I said, there is deeper and more detailed definitions of those if you so wish to look at those afterwards. In terms then of the national picture, folks, I suppose what we're just showing here is what is the area covered by these particular soils, and the column on the left is headlined there as mineral, but in the context of today, again, in the context of my interest in the poorer drained soils, it's the mineral soils that are imperfectly and poorly drained. So you're somewhere about 1.5 million hectares of those soils. If you go over to the right hand side of this slide, you're looking at the organics, so the peat and histic under that headline. Somewhere, depending on which estimates you look at, there is a bit of variation, but somewhere around 1.6, 1.7 million hectares. And then the humic soils, which are, as I said, a kind of a halfway house between the two, about 0.6 or 600,000 hectares on those in that category. So look, there's quite a lot of these soils around the place. For the peat and the histic, as we'll see as we go on, they're not all of that 1.7 million is under agriculture, so there's quite a mix there as well. But those are the headline figures, and those are what's mapped with the Irish Soil Information System a number of years ago. And there is, as always, I suppose, more work going on to refine those figures a bit further and to try and isolate soil types a bit further and draw boundaries, I suppose, on various mapping projects, looking at defining those a bit further. Okay, so if we look then at the mineral soils, first of all, measure 10, as I said, draining wet mineral soils. This is straight out of the MAC curve document. So just a small bit of text there. 1/3 of the Irish land area can be classified as poorly draining. Assuming that 1/3 of this area, or 10% of the total grassland area, was drained by 2030, is what's in the MAC curve of what the measure would be. And you can see there in terms of what changes here, that the measure is that you're reducing the nitrous oxide emission factor. So you have a higher emission of a factor for nitrous oxide from poorly drained mineral soils. So if they're drained, that reduces the cost then, and there is a cost associated with this, €16 plus 16.2 euro per ton of CO2 equivalent mitigated. The total amount there, metric tons, just shy of 0.2, and the total cost there, just over €6 million. The extended grazing then, as I said, this kind of falls into the remit of drainage when you start to read the fine print, I suppose. Measure 7, production systems that either require improved drainage or could benefit from on-off grazing. So again, the idea is here, if these soils were drained, there would then be the potential to utilize these soils in I suppose the shoulders of the year or longer throughout the year when the weather turned a bit adverse. If they were drained and not waterlogged, grazing could be extended on these soils, and then you have obviously better use of the resources that are there, and you're not importing feed and so on and so forth. So this feeds into a number of different positives in terms of what that might do in terms of emissions. It was assessed from 20% of the grassland area for these figures. So a negative cost there, as you'll see. So there's a benefit here in terms of this also has benefits in terms of on-farm production or profitability, production, reduction in cost. So there's actually a negative cost or a benefit there. The mitigation potential 0.066 of metric tons in terms of the cost then. So again, it's a negative cost, so there's a benefit there of just over 6 million. And that's what it looks like in the form that it's presented in the MAC curve document under the agricultural mitigation heading. You'll see there over on the if I can see, hopefully you can see that cursor, the drainage is over there. So there's a cost along this axis. Cost is here on the left-hand side, and there's potential mitigation, I suppose, along the bottom. So the width of the band indicates the mitigation potential, and the height of the band indicates the bar indicates the cost associated with it. And you'll see over here then in terms of the extended grazing. So again, it's on the positive side in terms of there's a negative cost and there's a potential as well saving there in terms of mitigation. So I suppose this measure is ties in, I suppose, very well with the heavy soils program. So the heavy soils program has been pushing a number of these measures for the last number of years, both in terms of pushing the drainage of soils in appropriate locations and pushing the extra utilization or the greater utilization of grasslands in terms of drainage infrastructure, grassland management, you know, improving soil fertility. All those elements are part of that program. And for today's purposes, I suppose I don't need to go into this in too much detail, but suffice to say there is different drainage systems developed that can be used in different soil types. There's two broad types of drainage scheme that are used, and these depend on the particular soil type that you're dealing with. A groundwater drainage system, a network of deeply installed pipe drains exploiting permeable layers, and a shallow drainage system. If your soil is heavy and infiltration of water is impeded, then permeability needs to be improved at all depths. So there's a system that's suited for that. So again, there is systems that can be put in place to drain these soils, and that's what we have been pushing, I suppose, in terms of the demonstration sites and heavy soils programs for the last couple of years. There's a bit more detail there in terms of how these systems actually work. As I said, the idea of the groundwater drainage system is that you're tapping into a reserve of groundwater and lowering the water table there through that natural capacity, I suppose, for water movement. The shallow drainage system employs the implements that you see there in the photographs to fracture and crack the soil and try and improve structure to get water moving off the surface. So again, it promotes water infiltration, it promotes drainage closer to the surface, and there's a number of different methods that can be employed there. And of course, all these methods, it's dependent on the soil type, it's dependent on what's possible in terms of landscape position and outfalls are. It depends on the economics. Certain enterprises won't justify the cost of some of these systems and so on. So there's a kind of a natural selection there of what fits where and what's possible where and what's possible financially and economically in different parts of the country and different enterprises. So those systems are in a number of years. We've monitored those sites in terms of weather, in terms of water table control, in terms of discharge. Excuse me. And I suppose what point I'm trying to make here is that we've shown, and there's a number of publications there that have shown how well or how these drainage systems are performing, how they suit particular soils, what the particular systems are, and what the outcomes are for these systems when they're installed on appropriate soils. Yeah, and the headline figure, I suppose, is where the right system is installed on these mineral soils. You're shown to reduce the overall period of waterlogging, improve surface conditions, and coming back to that extended grazing point, improving the capacity that these soils have for grazing or for use I suppose, longer throughout the year. And in line with that, then we have been pushing, I suppose, a number of both in terms of on-farm events, in terms of publications, in terms of different articles and events that have been held, to try and I suppose drive that message home that there is ways and means of appropriately draining particular soils, and how best to do it, and how most appropriately to do that in terms of accessing information on how that might be done. Okay, so the other issue then, as I said, is the measure 17, as it is in the MAC curve document, water table and manipulation of organic soils. And the fine print, as I said here, if drainage was stopped completely and natural water table conditions were restored on 40,000 hectares of re-wetted grassland. The nature of the measure, as you can see there, is as I've said, re-wetting of that 40,000 hectares. The cost is there, the mitigation potential, and a total cost then in terms of just over 4.8 million euros. So that's what's proposed. And like the MAC curve, all the measures, there are certain proposals put in, and depending on policy going forward, I suppose, will dictate how that's done. But this is the proposal, and that's the potential for mitigation and cost. In terms of land use mitigation, this graph is pulled straight from the MAC curve document again, and you see it there. If I can find my cursor again, which I can't find, there it is. Down here, you're seeing the water table management organic soil. So there's quite a bit of mitigation potential there in terms of the weight of that bar, and the cost, I suppose, there is a cost, but compared to some other measures, it's relatively low. So as I said, depending on how that's implemented, that is the proposed measure in terms of the organic soils. Okay, so this then is another figure from a Paul et al. Paper published in late 2018, looking at the total areas of the organic or the histic soils as they're described in this graphic, and the humic soils lower down on the right hand side here. So both the area on the bottom in terms of how many hectares, and the emissions that are coming from those soils. So as you can see there's quite a difference in terms of this estimate in terms of what the emissions are from the histic or the organic soils along this line up along mid-20s in terms of where it's sitting in the graph, versus the humic soils a lot lower, obviously, because there's lower organic matter content in those soils. It's worth saying, I suppose, and it's highlighted there on the bottom of the slide, the modelling that you're looking at was based on extreme drainage situation with a very high water table before drainage and a very low water table afterwards. Less extreme hydrological situations may result in lower emissions. So looking at that paper and looking at the studies that were done, and there's a number of other studies that I'll be showing in a moment, but suffice to say, I suppose, that this is an outer limit in terms of some of the potential emissions that are estimated. So taking, for example, the organic soils in that study looks at a water table being maintained in drain peats at 1.5 meters, which technically is possible, but would be very expensive and might be possible over small areas, but wouldn't be sustainable, certainly over numbers of years and decades in terms of over large scale areas. So it's a higher end if all these soils were drained fully, and if both in terms of the organics and the organominerals or the humic soil. So anyway, whichever way you slice it up, there's a good lot. There is a large amount of emissions coming from these soils, and the more organic matter you have, the higher that is. This is some other work that was done in terms of the table. When we look at the breakdown of that 1.6, 1.7 million hectares that I discussed earlier on, in terms of what that looks like in the different categories that are outlined there in the table. So if you look at what's highlighted with the red border there that popped up, the farmed peatland in that category in that table is categorized at about just shy of 300,000 hectares under grassland and under cropland. The last bullet point at the bottom shows the MAC curve assumption, which is about 370,000 hectares. So depending on what way you define these things and how they're accounted, you can get variation around that figure, but there is estimates there somewhere that order 300, 350, 370, and that 370 figure is drawn straight from more or less directly from that Paul paper that I showed a moment ago in that study in terms of how much drained peats were out there. So it's defining that, I suppose, what area of the total 1.6, 1.7 million hectares is under the remit of agriculture, and then going forward, how much of that is drained and how much of that can be undrained or can be re-wetted, I suppose, is the question going forward. So with that in mind, there have been a number of studies looking at mapping of the soils that are out there in terms of the soils I'm talking about, the organics, the carbon-rich soils as they're often termed, the histic and the humic soils, crossing that with land use and soil drainage class, and looking at the various different mitigation potential in terms of if those soils were to be reverted to wetter conditions, what the conditions would look like and what the mitigation might be. So some of these figures are this is from the Paul paper again. On the left-hand side there is obviously the map showing the organic or histic soils scattered throughout the country. And on the right-hand side is showing some of the high organic humic soils. So the green is showing the organic or the histic, and the different colors as you see there in the legend up on the top here. And these numbers refer to different soil series or parts of different soil series. So the obviously the ones that are most visible, I suppose, visually from what you're seeing are the purpley color, the yellow color, the blue. So there is a number of those scattered various parts of the country again, depending on your area of interest, but they're fairly widespread throughout the country. So what's already artificially drained, and this is an outer limit again, I suppose it's worth saying, 370,000 hectares of the histic soils, the organics, and 426,000 hectares of humic soils drained. So again, this is what's under the remit of agriculture. This is not to say that there isn't other organics that are drained for under other purposes or under other headings, as we showed in one of the tables 2 or 3 slides back. Okay, so we can move on to questions fairly soon, because I want to summarize this up. So the headline figures there, folks, I suppose the drainage of mineral soils is positive in terms of greenhouse gas emissions mitigation, and can also contribute towards extended grazing. Annual emissions are estimated from drained carbon-rich soils, so the ones we've been discussing, estimated up to 8.7 teragrams from histic soils, CO2 equivalent, and 1.8. So you can see even there again, if you take the headline figures, the organics are a lot more troublesome in terms of what the emission rates are, and this is from the Paul paper again, but it's an outer limit, but it is potentially what the potential is if all these soils were effectively drained, in terms of the headline figures you're looking at there. Lower down then, as we move down along the slide, national policy, obviously the reason we're discussing this, there is a recognition of the importance of preserving the carbon stock in the organic and humic soils, but there is, I suppose, a need for various different policy and various different procedures to make this reality in terms of how these are managed or minded or maintained going forward. And what we're looking, I suppose, to do now is get more and more information in terms of, we have an headline figure of what might be there in terms of drained soils under these different categories. But we need to refine that further. We do not know, as it says there, the area of drained organic soils totally and utterly. We have a lot of estimates and we're getting closer to knowing, but we do not have a final figure. We do not know how much has reverted to undrained conditions. So this is a very important, I suppose, point to make, is that if a drainage system was installed in an organic soil 20 years ago or 15 years ago or 30 years ago, the chances of that still maintaining a controlled water table, I mean, every drainage system has a limited lifespan, and no matter how well or how much is invested in getting the drainage system installed, it does tend to revert back in time, and in some soils it reverts back a lot quicker than others. But there is an assumption out there that a lot of the soils that are drained, there may be still an impact of the changing hydrology of the drainage system on that land area, but it's generally going to be not as extreme as one might assume, that in a condition that the drainage system was fully operating or fully working. So we need to get, I suppose, a better handle on that in terms of how much of these soils are actually drained and how much of them are effectively reverted back naturally over time, as various different schemes expire, I suppose, so to speak. And further research will need to explore the site suitability, cost effectiveness, as well as trade-offs and co-benefits of re-wetting. So if you take the figures from the MAC curve document of the cost in terms of the total cost to carry out this mitigation measure, there are certain assumptions taken there, but suffice to say that you're not taking the very expensive or the very cost inefficient parts of the country that this would be carried out in. You're taking some of the lower hanging fruit and looking at where the most effective ways and means of actually implementing this measure would be. And then you're looking at the trade-offs and the other benefits of re-wetting and how that might work and how that might sit with the landowners in question, and what, as I said, policies and what procedures would be needed to put in place to get this off the ground, and what value would be associated, I suppose, with these different soils from the different stakeholders that are there. This is a summary then, just the final slide, so I can stop talking after this, is showing the first three blue bars that we saw earlier. And then we're showing in the green just those upper limits of what's assumed to be drained in the humic, the organic soil, or the organic mineral soils, the halfway house as I described them, and what's drained in the peat and the istic at the upper end again. And from that, one of them is north of 400,000 hectares, one of them is south of 400,000 hectares, but they're in that ballpark. From that, then we're talking about 40,000 hectares as a minimum in terms of what's in the MAC curve, and trying to find from that column on the right-hand side, the 370,000 hectares. To get that 40,000 hectares, there might be, for round figures, might be 150,000 hectares of that's relatively low-hanging fruit, and depending then on, as I said, policies and procedures that are put in place, how do we get the 40,000 hectares out of that is where the conversation is going to go, and is already going, I suppose, in terms of how that might be implemented. So that is that is the final slide. So I suppose we can open up to questions.
It's great, Patrick. Thank you for that excellent presentation, and I don't think you left too many stones unturned there, if you pardon the pun. Pat, you spoke about the trade-offs in relation to re-wetting. But are there trade-offs in relation to drainage? In advance of today's webinar, I have been speaking to a few people, and we're discussing, I suppose, some of the notion of pollution swapping. Are there impacts on water quality from drainage? I know that there are concerns around that, and particularly inappropriate drainage.
Yeah, absolutely. The concerns are there, and I suppose what we're trying to get at is putting in systems that are appropriate in terms of suiting a particular landscape position or suiting a particular soil type. I mean, when you install any drainage system, you're going to change the dynamics, I suppose, of how water leaves that particular system. So an undrained farm or undrained field or undrained part of the country has, if well, we've had a relatively dry weather recently, but if we had a wet period like we had back in February, rain being added to that system is leaving as overland flow, or is leaving as groundwater, is leaving the system anyway. When you put in a drainage system, you change the dynamics of how that leaves. So it might leave at a, having interacted with a different part of the soil profile, it might leave quicker, it might leave through avenues and have, as I said, different connections to different parts of a regime in terms of a soil profile or whatever. So we do need to be careful in terms of mitigating against that, and a number of different pieces of work have been carried out over the last number of years, and like I said, I suppose kicking off, Mark, there is horses for courses in terms of how you deal with particular soils. So the losses that I suppose you can't say that losses will be, a drainage system will create X, Y, or Z in terms of losses. It very much depends on the management practices on that particular piece of land and the soils and how they mitigate against that. So I discussed there deeper and shallower drainage systems as well. That's another variable in terms of what the water leaving a farm interacts with. That's very different in terms of whether the system is shallow or whether it's deep, and what soils it's interacting with along the way. So
it's really important to get good advice when someone is considering a drainage plan. I know you run a course, an excellent course on this, and perhaps there will be some requirement for people to seek advice when doing drainage, because I know, Pat, you often say, and I've heard your colleagues say, inappropriate drainage can cause more problems, or inappropriate solutions may not solve the problem and even cause further problems. I presume that also goes for greenhouse gas emissions, that where you have an inappropriate drainage system or design put in place.
Yeah, so as you mentioned, we've been, I touched up it there, running a number of different courses and workshops over the years to try and spread the gospel on this to a certain degree. So yeah, that's a fair point. And it's worth bearing in mind on any particular farm that we'd be involved with, or that we would be running a different events on, or visiting for different events. There would be, there's never really a case where you have 100% of a farm that's artificially drained. You might have 20%, and that might rotate around as systems get rejuvenated and as their lifespan kind of ends again. So that then obviously you have an opportunity to select for avoiding troublesome areas and avoiding maybe floodplains or areas that are having an overtly negative impact, and picking and choosing in terms of what might be the best or most appropriate place to put a drainage system and how to monitor that. And there's also work going on in terms of mitigating losses. So as I said, whether a drainage system is in place or not, there is water leaving a farm and a piece of land. So mitigating against that, I suppose, is where we need to look at going forward as well.
Okay, Pat Murphy.
I suppose a couple of questions coming in, and a few around the kind of topic of what might a re-wetted soil, organic soil, look like, and what kind of uses can be made of that, or what kind of benefit can they derive from that, I suppose, both agriculturally and environmentally. So
if these soils, and again, there's the question of how much of them are out there that are drained to significant depth, but if they are re-wetted, you change the regime, and look, a water table is a fluctuating thing, but you could take a mean water table from being a meter or a meter and a half deep up to half a meter or close to the surface. Then you change how that soil behaves. So there's less potential for less losses then, in terms of the carbon levels that are there can be maintained longer. And then depending on the regime and depending on the important point, I suppose, is that you're manipulating the water table. So you're not necessarily inundating this piece of land if it wasn't originally inundated with water. So there may be still scope there for particular practices or particular management to go on. It all depends on what level you're required to bring the water table back to. So there is a huge, I suppose, question there in terms of, as I said in the summary, what value different stakeholders put on the different land that's at play here, and how we kind of set up policies around that is going to dictate how this goes in terms of the value that we can see out of it, both from the landowner's point of view and the broader questions of the mitigation.
Okay, just I suppose a related question to what Mark was talking about, and it's one here: the reduction of N2O from drained land is obviously a benefit in terms of greenhouse gases. But what about water quality? Draining can increase the losses to water. So how does the benefit of reducing greenhouse gases versus water quality weigh up? And I suppose the related question to that is mentioned is the balance between losses of N and losses of P, where I suppose there's a potential that the losses of P, which are normally overland flow, are potentially reduced, but nitrogen may be increased. Yeah,
so there is that issue, and that gets to the heart of it really, Pat, that the dynamics of how the losses occur changes. So generally speaking, and international research would show that from various parts of the world that you're likely to get increases in N losses, but you're reducing P losses because you're reducing overland flow and sediment losses, in particular P losses. So there has to be a balance there. It goes back to what Mark asked earlier, in terms of what the potential for losses here, what the overall benefit is, trying to mitigate against those losses, and there is ways and means of even simple things like sediment traps, prevention of bank erosion, those kind of things that can be done by proper planning, I suppose, and by working to a plan, and as I said, picking the areas of the farm that are most beneficial and least troublesome in terms of what the other impacts might be, and utilizing that as best you can.
Pat, I have a technical one for you. I'm just going to read it out to you. It says, full wetlands accumulate carbon very slowly as peat because most fresh organic matter from photosynthesis deposited in such an anoxic conditions gets converted to methane. And if we believe the IPCC, that methane is 28 times more powerful GHG or greenhouse gas than CO2, does this not make new man-made wetlands greater sources of global warming methane than any advantageous carbon sinks?
Yeah, well, I mean, it depends on what you call a man-made wetland. I mean, total artificial wetlands are treated differently in the IPC document, which I don't have to hand, but in terms of the emission factors that are there is different assumptions made for constructed wetlands. And in terms of the redevelopment of the organic matter, yeah, there is a difference, I suppose, in terms of it's not like flicking a switch and potentially reverting back immediately, but there is the potential there for the development over time of that, and there is an immediate effect in terms of relatively immediate effect of stopping any more losses that would occur in the next year or decade or so on. So there's different ways of means of accounting for the different, if we're talking about man-made wetlands or re-wetted carbon or undisturbed carbon banks. So that we're talking about a number of different things there, I suppose.
Yeah. And Pat, Professor Gary Lanigan, who we spoke with a few weeks ago, he talked about the peatlands as our rainforests. And I thought it was a good analogy. What's going on at a national level there, Pat, to try and realize the benefits of that re-wetting? Are you aware of the programs that are underway there? I know Bord na Móna are embarking on some programs around re-wetting.
Yeah, so there is a number of different stakeholders involved. Like I highlighted there is, we take the round figure of 300,000 hectares under grassland and cropland. So take that as being agricultural. Under the agricultural remit, there's a lot more. There's another 1.3 million hectares that is out there, and there's a number of different, be it universities or Teagasc or different bodies that are looking at how that might look, what that might look like in terms of the benefits that are there. From I suppose our point of view, it's coming back to what I summarized there at the end, trying to define how best to find those 1,000 hectares, what approaches might be taken to try and get that land area into this kind of a scheme, and looking at, you know, greater definition of where those lands are, and how to effectively draw them in under this heading, I suppose.
Mark, and I think there was another, I suppose, suggestion rather than a question in the identification of those 40,000, that we take a balanced approach between the greenhouse gas mitigation, biodiversity, and water quality when we're looking at those and looking at the future management of them. I think maybe that's more of a comment than a.
Yeah, that's a fair comment.
Just, I suppose, a fairly technical question. How are the emissions factors calculated for the organic rich soil? Is it direct measurement, or is it through use of IPCC factors or standards? And does it include DOC as well as CO2?
Well, there's a kind of a chicken and an egg there to a certain extent, Pat. I mean, the IPCC standards are derived from numerous studies and direct measurement, and then there is ways and means of applying those to particular land types or particular scenarios. And then there is continuing work to try and make those emission factors more appropriate or more accurate for particular parts of the world, or for particular scenarios in terms of be it soil types, or be it, you know, all the various different elements that are under this in area. So it's depending on what's available, I suppose. If there is more appropriate data available for a particular scenario in question, then that would be the go-to. If there is emission factors that need to be drawn from IPCC work that's, again, derived from direct measurement effectively, that would be the go-to. So that depends, I suppose.
I suppose one question there is just a procedural. Will the PowerPoint be available? Just to say, yes, they will be available, and the full talk will be on the Teagasc website. Usually goes up the afternoon of the morning of the day of the presentation. Mark.
Okay, so I think there's a point of clarification there, just coming from a colleague here. It says the emissions of methane from wetlands is accounted for within the IPCC calculations. The net benefit is a large carbon sink. So that's kind of complements what you were saying. Yeah.
Sorry, just on a related topic. There's a question there about do we have any indication of what is happening or is being planned in relation to the Bordemona peatlands now that we're looking at an end to harvesting for energy production? Yeah,
well, I mean, that's under the remit of Bordemona, I suppose, but it would be a similar view being taken in terms of how best to combine the benefits of greenhouse gas mitigation, increasing biodiversity, water quality, and so on. How they're actually doing that on a practical level, I can't say, Pat, to be honest.
Okay.
There's a question here in relation to the extended benefits of drainage in terms of reducing the amount of imported livestock feedstuffs. Has that been accounted for in the calculations, Pat, or this, that the extended grazing, you're increasing the amount of grass in the diet, and therefore reducing the necessity to supplement?
Yeah, so again, that would be accounted for in the on measure 7 of extended grazing. So assuming that a certain portion of the land allowed for more utilization of grass and extended grazing, then there is a knock-on effect there in terms of lower usage of imported feedstuffs.
Okay, very good.
Question, Pat, is in terms of the mineral soils that when they're drained, is there an impact on the organic matter content of those mineral soils when they have been drained?
Bear in mind, I suppose, that the organic matter within those soils is somewhere of the order of less than 10%, 2, 3, 4, up to 7, 8% typically. And that is sustained within the surface horizons and in close to the surface, generally speaking. It would be relatively minor, I suppose, in terms of compared to the amount of organic matter that would be in the carbon-rich soils, as they're termed.
Pat, you mentioned the Irish Soil Information System in your presentation. Could you tell us a little bit about that? And it is a publicly available resource. And I think it might be useful for people here today to refer to it. Yeah,
so the Irish Soil Information System is available online. A quick Google, I suppose be careful about Googling that acronym. But they have a number of different resources there in terms of how the whole process was done, the mapping and the procedural setup of how the maps are put together, and a searchable map in terms of a probability map of soil associations that can be clicked on at any part of the country. So and background information in terms of the soils from which those classifications were derived. So there's a lot of information up there. Irish Soil Information System. A quick Google should find it fairly easily.
Thanks, Pat. We have a question. It relates to forestry, but we might ask it of our forester later on. But it asks about is there any research done on agroforestry for the draining of mineral soils? Are there benefits to that as I suppose as a natural form of drainage?
Yeah, and that is another area that's being looked at. Again, I suppose Tom Houlihan will be here in the next few weeks and has a better handle on the different approaches that are being taken there. But yes, there is a view that could be another potential measure. Very
good. Pat, do you have any more questions there?
We're kind of run out of questions. If anybody has any more to get them in.
Yeah. A lot of questions around Board Mona and the rewetting of peatlands there. We have a question here: as part of soil management nutrient plans for individual farm, is soil type and drainage taken into account? At the moment, I don't believe it is formally part, but it would be part of the decision-making process by an agricultural advisor. But maybe that's something, Pat, that should be incorporated into nutrient management planning.
Well, in fact, in the latest version of NMP Online, we are taking into account the soil type between light with different recommendations now possible for lighter soils, heavy soils, and peat soils. So yes, that is ongoing. I suppose up to now it was kind of a single recommendation, but that in the latest version is now being taken into account.
The soil type itself, yes, is taken into account.
On a field by field basis, you now can enter the type of soil that's in that field. As I say, it's not hugely differentiated. It's just a light or dry soil, a heavy soil, or peat.
Okay. So I mean, yes, I do see that something that will be far more prevalent during farm visits, and will be, we have a lot of advisors have completed that course that Pat that you have delivered. It's available to the private and public sector. Is that right, Pat Tuohy?
Yeah. So that course has run now for a number of years, and we've had, you know, approximately 80 people on that course. So from all parts of the country and from all a number of different groups. So a number of our own advisors, private advisors, agricultural contractors. So it's has run a number of years and will run into the future again.
Okay, Pat. Unless you have any other burning questions there, I think we'll.
I think we're through most of what's come in.
Okay, so look, it leaves for me to say thank you, Pat Tuohy, for an excellent presentation. Pat Murphy, thank you very much for your support on the questions. What I'd just like to remind everybody that today's webinar has been recorded, will be available on the YouTube website, the Teagasc YouTube channel. If you're interested in hearing more from Teagasc, please do look at the Teagasc ConnectEd webpage, where you can sign up for free updates on latest developments, events and training in relation to Teagasc, particularly targeted at rural professionals. And I also want to thank as well as Pat Murphy, Andy Boland and Yvonne Maher, and of course our partners on this series. Next week I'll be joined by Jack Nolan, who's Senior Inspector with the Department of Agriculture, Food and the Marine, where we'll be looking at Ireland's nitrates derogation and what is involved in the review of that and how we can secure that derogation over the next number of years. So with that, I want to thank you for your attention today. I hope you have a lovely May Bank holiday weekend, while of course observing the current restrictions. So until next Friday, thank you very much.